Hi guys, welcome to Deep Diver. In this video, we will discuss slices, which is one of the most heavily used data structure in Golang and provides a more powerful alternative to arrays. Unlike arrays, slices have a dynamic size, which basically means their length can change at the runtime. If you have worked with languages like C++ and Java before, there also we have a similar concept where in C++ we prefer using vector instead of an array, and in Java we prefer using list over an array. Similarly, in Golang we have slices and we prefer it over array because slices have dynamic size. Let us see how we can create a slice in Golang. So this is my Golang course folder, and here I have already created a folder 10 underscore slices, and inside this folder I have already a file called slices.go, and in that slices.go I have added the package main and the function main. So we are good to go. Creating a slice is similar to creating an array, but just with a subtle difference. So how do we create an array in Golang? Array colon equal, then we give the square brackets. Inside this square bracket we give the size, then the data type, and then we can provide the values of all the 5 elements here. So this is how we create an array. If you want to make it slice instead of array, just remove this size from this square bracket. Okay, and now it has become a slice instead of array. So if I want to print this, I have added this print statement. Now let us go to terminal and run this. If we run this with go run slices.go, you can see 1 2 3 4 5 getting printed in order. Okay, now how does this slice provides this dynamic size behavior? So internally slices maintains an array only. Whenever we want to create a slice like this, so what Go does is internally it creates an array of a fixed size and then it uses that array as part of this slice. Okay, so slice has along with this array two more things. One is the length and other is the capacity. The first thing the slice has is a pointer, and this pointer points to the first element of the array. Okay, so every slice maintains an array, so you can think of slice as a wrapper over an array. Okay, so first thing is it contains a pointer which points to the first element of the underlying array. Second thing is it maintains the length, and the length is basically number of elements in the slice. Next, this slice maintains capacity as well, which is maximum number of elements this slice can hold without reallocating. So if this capacity definition does not making sense to you, bear with me for some time, it will. Okay, so slice maintains three things. So let us introduce a function. I will name this function as print slice detail, which will take a slice and print all these three things. Okay, so this function accepts a slice. So if I add the size here, it will become an array instead of a slice. Okay, but we want a slice here, so let us keep it like this. First thing we will add is fmt.printf address of the first element of the array. Okay, so we can get this using %p, and then we will pass slice to this printf. Then we also want to print the length and the capacity. So length %d, capacity %d. Length we can get using len function, pass slice into this less function, and then capacity you can get using cap function. We also pass this slice here. Now if I call this function print slice details and pass the slice here, let us see what does it print. So go run slices.go. Okay, so let us add a new line here as well, lesson. Okay, so let us clear this and run this code again. So here you can see it is printing the array 1 2 3 4 5 and then the address of the first element of the array, which is this. Okay, and the length here is 5 and capacity is also 5. So in this case the length and capacity is same, but this is not always the case. So as this slice can have dynamic size, let us try to add some more elements to this slice. How we can do that? We can do that using append function. Let us use the append function and add some more element. So slice equals, we'll use append function, we'll pass the slice here. Let us say we want to add two more elements, 6 and 7. Okay, again we will print the slice and the slice detail. Let me copy paste this. Now let us run this again. So here if you see, initially the array was 1 2 3 4 5. Okay, length was 5, capacity is 5. Now we added two more elements, 6 7, and now the address of the first element of the array, it is printing. Length is now 7 and capacity is 10. So here if you see, capacity has been doubled. One more thing to note here, notice the address of the first element of the underlying array in the slice. These are not equal, right? Why is that so? So whenever the current capacity of the slice is not enough to accommodate the new elements, what Go does is it creates a new array and copies all the elements from the older array into the new array and then appends whatever the new elements are. Okay, so that's why you see the address of the first element after appending is different from the previous address. Okay, now let us do one thing. Let us add two more elements here. Instead of 6 7, we'll do 8 9. Okay, and let us run this again. So what will happen here, we are adding two more elements. Before that the slice length was 7 and capacity was 10. So 7 plus 2 is equal to 9 is less than the capacity. So in this case, as the capacity is enough to accommodate these two elements, no new array will be required. Okay, so this print slice detail should print the same address as this print slice detail on line number 23. Okay, so let us try to run this code. Let us go from the starting. Okay, first it created a slice of 5 elements. Okay, length was 5, capacity was 5. Then we added two more elements, so length has become 7, capacity has doubled. Okay, so address of the first element of the array for these two are different. Okay, why? Because a new array of capacity 10 was created and the elements from the previous array was copied into the newly created array, and this 6 7 was appended to this newly created array. That's why you see the address here is different from this. Then we add two more elements, 8 9. Okay, but this time total number of elements is 9, which is less than the capacity, so there is no need of creating a new array. That's why you see the address here and the address here is same. Okay, now just to extend it further, what happens if I add two more elements here? What will happen? So up to here the capacity was 10, right? And now we are adding four more elements. So 7 plus 4 is 11, which is exceeding the capacity. So in this case again, what will happen? A new array will be created. All the older elements up to 7 will be copied, and then to the newly created array 8 9 10 11 will be appended to the end. Okay, so as a new array is getting created here, so address here will be different from the address of this slice. Okay, so let me run this code again and show you that. So this time every address is different because every time we are appending, we are exceeding the capacity, and that is leading to creation of a new array. That's why you see the address are different every time. Okay, now let me ask you a question. Here if you see in the output, every time append operation is done and the capacity is not enough, the capacity is getting doubled. So initially it was 5, then 10, then 20. So my question is, whenever the capacity is not enough, will the capacity get doubled every time? The answer is no. So for smaller values, the capacity will get double, but for larger values, it will not get double. It will increase, but it will not get double to optimize the memory use. Okay, now let us move further and look into other ways of creating slices. So let me comment this code. Okay, and Here we will try to create a slice using make function. Okay, I will create a variable mslc colon equal. We will use make function. We'll give the type here. So we want a slice which keeps integer elements. Okay, so we'll give the type as square bracket int, and then here we can pass two things. First is the length. Let us say the length is 4, and then the capacity. Let us keep the capacity as 9. Now let us try to print this fmt.println mslc. Okay, so what does it will print? It should print the slice of length 4, and what should be the values in that slice? As we are not initializing the values here, all should take the default 0 value, which is 0 for integer. So we should get a slice of 4 elements with values all set to 0. Let us run this code. Go run slices.go, and you will see it is printing a slice with all the elements set to 0. Creating slice using this make function has an advantage. If we know the capacity in advance, then we can create a slice with that much capacity in starting only, and that will save us from creation of new array and copying of the elements from the older array into the new array when the append function is used, right? Also, the first way of creating slice is not very scalable. Let us say we want to create a slice of 1000 elements all having value 0. So what we'll do here, we'll do like this: 0 0 0 1000 times, right? Which is not very scalable. So in production as well, generally we use this make function to create arrays. Okay, now let us look into one more way of creating slices. Okay, so I will comment this existing code. Okay, so we can create slices from an existing slice as well. Let me create a slice first. I will use make function now. Let us say the slice length we want to keep it as 8. Okay, and I will use for loop here. For I colon equal to 0, I is less than 8, I plus plus, and slice of I is equal to I. So we will get a slice with the elements 0 to 7. Okay, so let us print this as well. fmt.println slice. If I run this code, we have a slice with 8 elements starting from 0 and ending at 7. Okay, so now we can create a slice from this existing slice. How? Let us see that. So I will create a new slice, slice 1, and we'll give the slice, and then we give the square bracket, and in this square bracket we need to provide two indexes separated by colon. Let us say I want the values from 1 to 4. Okay, so the first index I am passing it as 1, and then the second index I am passing it as 5. So I want the value from 1 to 4, but I am passing the index as 5 here. Why? Because this second index is excluding. Okay, so let me print this slice 1. I will also add a string slice 1. Okay, so if I run this code again, you can see slice 1 is printing 1 2 3 4. So keep in mind that the second index is excluding. Now let us say I want to create one more slice. This time I want all the elements starting from index 2. Okay, so this time I will give the first index and 2, and since I want all the elements starting from index 2, okay, so either I can give it as 8 here, or better way is to leave it blank. Okay, so here what we are telling, we want everything starting from index 2. So if I print this slice 2 slice 2 slice 2, so here you will see f is missing. Okay, so here you will see it is printing slice 2 starting from index 2 and going up to index 7. Okay, similarly we can create one more slice. Here we need all elements starting from index 0 and up to index 5. Okay, so we can do it a similar way. First index we will keep it blank, and for the second index, as we want to print up to 5, and the second index is excluding, we need to give it up to index 6. Okay, so this will print up to index 5, right? So 0 1 2 3 4 5 should get printed. Now run this code again. So you can see 0 1 2 3 4 5 got printed. So here I use slice 2. Let me change it to slice 3. Okay, now let me tell you one important thing. Let us say I modify slice 1 index 1 with value 2000. Okay, what do you think gonna happen? So let us run this code again. You see, when we did modification on slice 1 only, other slices, slice 2 and slice 3 are also getting modified. Why is that so? So when we create slices like this, these slices are still pointing to the original slice. Okay, so if this slice was here 0 1 2 3 4 5 6 7 like this, and then we did slice 1 is equal to 2000, so this 2 basically was modified to 2000. Okay, and other slices, slice 2 and slice 3 are also referencing the same slice, so that's why you see slice 2 and slice 3 getting impacted as well. Okay, so this problem is known as slice sharing problem, where if you create multiple slices like this from an existing slice, if you modify any of the slice, then that impacts other slices as well. So what is the solution for this? The solution for this is copy function. So let me create one more slice copy, I will name it. Okay, now I will create this slice using make function. So I'll give the data type, then the length. I want this entire slice to be copied. Okay, so I will pass length of slice here. Okay, and then we will use copy function. So copy, then slice copy. So first we give the destination, okay, where we want to copy, and then the source. The source is ours, SLC. Okay, and then I will print slice copy as well. So if I run this code again, so if you see here, you see slice 1 is getting modified, slice 2 is getting modified, slice 3 is getting modified, but not the slice copy, because copy gives you basically a separate copy. Okay, so now let us look into one last thing, how we can iterate our slices. So to iterate over slices, we can use for with range. How to do that? So for index value colon equal range over, let us say, slice copy. Okay, and then we can print the index and the value, fmt.printf. Okay, so index %d value %d, and at last we'll add a new line here. Okay, and we'll pass this index and value. As this slice copy has too many elements, let us replace this slice copy with slice 1. Okay, slice 1 has only 4 elements. Okay, so like this you can iterate over a slice. So index 0, index 1, index 2, index 3, and their corresponding values are getting printed. One more thing I want to tell you is, let us see, I don't want the index here. Okay, so how I can do that? If you don't want the index, then you can use a special variable underscore, which is kind of write only variable. Okay, so we can get rid of this index from here and from here as well, and then when we iterate over this array, we are discarding the index but only keeping track of the values. So if I run this code again, go run slices.go, we'll see only values are getting printed. So this underscore, you can think of it like as a trash can, where you can put values but you cannot take it out. Okay, so this is it for this video. See you in the next one.